Hi, everybody. We're going to continue to study quadrilaterals and parallelograms today. Our objective is to be able to determine whether or not a quadrilateral on a coordinate plane is a parallelogram. So first, I just wanted to make sure that we remember those key vocabulary words that we've been studying. A quadrilateral is a shape with four sides. And we want to know what makes a quadrilateral a parallelogram. So it's going to be important to know that definition in order to be able to do the work that we're going to be doing on a coordinate plane. So the key thing to know about parallelograms is it's a quadrilateral with two pairs of parallel sides. So let's think about what we know about the coordinate plane and how to determine whether or not segments are parallel. And that's going to be the key for our success today. So let's look at a few examples. And you can jot these down in your notebook and take some good notes so that you can use it to apply to some problems in a few minutes. So first of all, what if I give you a graph of a quadrilateral? How do we determine whether or not this quadrilateral is a parallelogram? So let's look at its opposite sides. So let's look at AB and at CD, and we can determine whether or not those are parallel using slopes, because we know that parallel lines have the same slope. So I'm going to use this little m for slope and find the slope of AB. And then I'm going to use the little m for slope again and find the slope of CD. And if the slopes are the same, then those segments are parallel. So to find the slope of AB, I'm just going to count to get from B to A. You go down 1, 2, 3, 4 boxes and over to the right 1 box. Down 4, over 1. Notice that my slope is negative because the line segment slopes downhill. Now I'm going to do the exact same thing with CD. Down 1, 2, 3, 4 boxes and over 1. So yep, those two line segments are parallel. Now let's check the other two line segments. Let's check and see whether BC and AD are parallel. So I'm going to find the slope of BC, and then I'm going to find the slope of AD. And again, I think the best way to find slope when you're given a graph is just to count the rise and count the run. So to get from B to C, there's a rise of 2 and a run of 1, 2, 3, 4, 5. Up 2, over 5. BC slopes uphill, so it has a positive slope. And let's find the slope from A to D. Up 2 over 1, 2, 3, 4, 5. All right, what I'm seeing is that we have two pairs of opposite sides that are parallel. So I'm going to say, yes, ABCD is a parallelogram because it has two pairs of opposite sides that are parallel. What if you're not given a graph? What if you're just given 4 points? So that's going to be our next example. Let's determine whether or not EFGH is a parallelogram. And then I gave you coordinates for the 4 points. We could plot those 4 points, but I'd actually rather just look at slopes like we did in the previous example. I do kind of like to make a little sketch at least. This is not very accurate, but I like to just put EFGH on a quadrilateral and see which sides would be the opposite sides that I'd be looking at. So EF and GH are opposite sides. So let's look at those. Let's find the slope of EF, and then let's find the slope of GH. So when I'm finding the slope of EF, remember that I need to find the change in the y coordinates first. That's how you find slope. And then in the denominator of the fraction, I need to find the change in the x coordinates. So 5 minus 2 is the numerator, and -4 minus -8 is the denominator. 5 minus 2 is 3. -4 minus -8 is 4. So the slope of EF is 3/4. Let's do the exact same thing with GH. We'll find the change in the y values, and then we'll find the change in the x values. So the change in the y values for GH is 1 minus 4 over negative 2 minus 2. That's the change in the x values. This one, at first glance, this is going to look kind of funny. Negative 3 over negative 4. At first, we might think that those two slopes are not equivalent to each other, but a negative divided by a negative does give you positive 3/4. So yes, those two are parallel. Now let's check the other two line segments, EH and FG. So let's find the slope of EH and let's find the slope of FG and see if those two slopes are the same as well. So EH, I'm going to find the change in the y values and then the change in the x values. 1 minus 2 over negative 2 minus negative 8. 1 minus 2 is negative 1. Negative 2 minus negative 8 is 6. So finally, we need to find the slope of FG and see if that's equivalent. So 4 minus 5 over 2 minus negative 4 gives you negative 1 over 6. So is EFGH a parallelogram or not? You can pause the video for a second and think about your answer and see if you can come up with a reason why. All right, when you're ready, the answer is yes again, because it's a quadrilateral with two pairs of opposite sides that are parallel. So you will see examples in your practice where they don't turn out to be parallelograms. And for example, if we found the slope of EF and GH, those would be different. They wouldn't both be 3/4. One of them would be 3/4 and one of them would be something else. So look for that to come up in your practice problems. I have one final problem for you to take a look at. What if I give you 3 of the coordinates and I tell you that I want you to graph a parallelogram, but I don't give you the 4th? So we could plot this on Desmos and come up with a nice complete graph, or we could make a quick sketch. So I think it's a good math skill for future math classes to be able to just make a quick sketch. So here's what I do. If P is 1, 5, I just make a little sketch of where 1 would be on the x-axis and then kind of eyeball where 5 would be on the y-axis and plot the P. So let's try to do the same thing with A. A is 8, 5. So I'm going to go over to 8-ish on the x-axis and the y-axis, the y-coordinate, that's the same, 5. So that's my A. And then finally, I'm going to plot R at 10, 11. So 10 is a little past 8, and then 11 is going to be way up here somewhere. 10, 11. So that's R. So I'm going to connect the points that I did plot, and then I can kind of tell where my L needs to be in order for this to be a parallelogram. It needs to be somewhere over there. So I like to complete my sketch so that I can at least come up with a good estimate. So I know one of the coordinates for sure. So let's pause the video for a moment and see if you can think about what you do know for sure about the coordinates of point L. All right, when you're ready, what I know for sure is that the y coordinate is L, because since PA is horizontal, LR has to be horizontal because opposite sides in a parallelogram are parallel. So I know that L is going to be something, 11. Let's use slopes to figure out what the x coordinate needs to be. So I'm going to find the rise and run of AR. So my rise goes from 5 to 11. 11 minus 5 is 6. And then my run, the x values go from 8 to 10. So 10 minus 8 is 2. So I need my rise and my run for PL to be equivalent to my rise and run for AR. So my rise is still 11 minus 5, which is 6. So my run needs to be 2. So pause the video for a quick moment, see if you can figure out what the coordinates of L should be. All right, when you're ready, I just need an x coordinate that's 2 more than 1. 1 plus 2 is 3. So the coordinates of point L are 3, 11. Now we're going to try some practice problems on your own. So let me know what your questions are, and let's get ready to practice. Bye.